equation relating the relation between pressure and volume in PV plane as PV raised to N is equal to C, where again P is the absolute pressure, V is the volume or specific volume of a certain working substance or ideal gas, and N being the polytropic coefficient that will define the process that the ideal gas will undergo. So please take note that this N is different from the PV is equal to nRT. Okay, so this N here, okay, is the polytropic coefficient, okay, or the polytropic index. Okay po. The other one is yung sa PV is equals to uh, nRT, where N is the amount of substance in moles. Okay, so and describing the processes of a specific ideal gases like heat, work, etc., the application of equation of state, characteristics of a perfect gas, and additional relevant formulas that will control the behavior of the working substance being considered are still inevitable. Subsequent discussions will demonstrate how the characteristics of ideal gas can be mathematically defined. So these processes of ideal gas and their governing equations will serve as tools in analyzing advanced thermodynamic problems. So for the intended learning outcomes, we have three. So the first one is to identify the 7 general equations as used to derive the ideal gas processes. Second, to derive and discuss the different processes of an ideal gas. Third, and last, analyze and solve problems on different processes of an ideal gas. So let us proceed with the first main topic, which is the 7 general equations. Okay, so everything again that you have learned from especially on chapters 2 and 3, okay, we'll be using those topics here po in order for us to define the behavior of ideal gas undergoing a certain process. Okay, so these 7 general equations, okay po, will serve as a guide, okay, in deriving equations necessary in calculating various ideal gas behavior. Okay, so we have here the 7 general equations. Okay, so the first one is the PVT relations. Okay, so isulat natin dito. Alright, so the first one is the PVT relations. Okay, sulat po natin dito. Okay, one is PVT relations. Okay, so for this one po, okay, to define the behavior of ideal gas under any process, we must use the relation of the combined gas law, which was discussed during our chapter 3, which is equal to PV, okay, all over T is equal to C. Okay, whereas it can be also written, okay, in PV over T now initial, okay, which is also equal to PV over T ng final po. Okay po, so it can be written in that way po. Okay, so in that equation po, we can relate the three parameters such as the pressure, volume, and temperature between the ideal gas processes state points. Okay, so knowing that we have here the initial and final state. All right. So please take note that you have to use, okay, always the absolute values for pressure and temperature. Ibig sabihin, okay, most of the time naman the given problems in solving such or related to this topic, okay, laging ang given naman dun is absolute pressure. Pero just in case hindi, if the given is gauge pressure, you have to add an atmospheric pressure in order for you to obtain an absolute pressure. Okay? And then, sabi din dito, we should use also absolute temperature. Meaning, in solving such problems, you have to convert yung pong ating degree Celsius and degree Fahrenheit to Kelvin and Rankine respectively. Okay? So, always remember that. Not only in PVT relations, but in all equations that uses, okay, or that use pressure and temperature. Okay, you have to use the absolute pressure and the temperature. All right. Okay, so the second equation, okay, is the work non-flow. Okay, work non-flow. Work non-flow. Okay, so for this one, the equation that is being used, okay, is equal to Wn is equal to the integral, okay, of P D V from point 1 to 2. Okay? So by definition, okay, by definition po, non-flow work rather is the area under PV plane which represents the total work done of the ideal gas as it changes its volume and pressure between two state points. Okay? And so that is for work non-steady flow. And then we also have here the work steady flow. Okay? For work steady flow naman, okay? Yan, work steady flow. Our third general equation is for work steady flow. Okay, work steady flow. Okay? For the work steady flow, all right? So we use the formula W subscript S negative integral of V dP. Okay, from point 1 to 2. Okay, so by definition, a work steady flow is also the work done of ideal gas as it crosses the boundary of a certain thermodynamic system thus maintaining a steady state flow condition. Sir, ano difference po ng work steady flow from work non-flow? Okay, so the difference between the two is that mostly work or actually all the time, okay, work non-flow, okay, is obtained in a closed system. Okay, while work steady flow are or is obtained in an open system. Okay, so please take note of that. Okay, so work non-flow, ibig sabihin there is no mass transfer. Okay, but energy only. Okay, only energy can transfer the or can cross the boundary. Well, so, while sa work steady flow naman po, ibig sabihin it is mostly in an open system, okay? Which means there is mass and energy that is crossing the boundaries po. All right? And then, for the fourth equation, we have a general equation for heat. Okay? Heat. All right. So for heat, okay, we have the equation Q or heat is equal to delta U or integral or internal energy rather plus work done flow. Again, work done flow is simply equal to delta PV, which will give us an equation for heat as internal energy plus delta PV. Okay, so I do hope you still recall these equations from the topic of forms of energy. All right, so this one, the last three, it's more on recalling na lang, okay? But we also have a general equation for internal energy. For internal energy or U, okay? For the internal energy. Again, internal energy is the sum of all the microscopic forms of energy. And we can use the equation for internal energy as delta U, okay, delta U is equal to mCV delta T. Okay, where delta T is equal to the final temperature minus the initial temperature. Okay, we also have here the general equation for enthalpy. Okay, or symbol H. Okay, for enthalpy. Okay, for enthalpy, again, we have an equation for enthalpy or delta H equals mCp delta T. Okay, so remember the specific heat constant for internal energy is Cv, while for heat or enthalpy rather, is Cp. Okay, and then lastly, okay, lastly, we have the equation for entropy or S. Okay, for entropy, entropy is equal to the integral of dq over T. Alright, from state point 1 to 2. Okay, sabi din dyan where Q is heat transferred and T again is the absolute temperature. Okay, so please take note of the following equations. Okay, so again, by utilizing the seven general equations provided, we can derive and establish equations in every process of ideal gas to calculate the necessary parameters such as heat, work, and other relations. Okay? Yan. So that is the seven general equations. So please take note of this. Please do memorize. Please do familiarize yourself with the following equations. Kasi possible lumabas siya sa ating quiz. Alright? Okay? Quiz next week. Okay? Kakaintindihan po tayo? Okay. So, moving on. Let me erase this first. Okay. So, the processes of ideal gas. So, let's proceed with the processes of ideal gas. Okay? Focus tayo dito sa ating module. Okay? Again, any process of an ideal gas can be well presented by the equation AV raised to n is equal to C. Again, where n is the polytropic coefficient. Okay? N again is the polytropic coefficient or polytropic index. Okay? This n, again, will define the process that the ideal gas will undergo. Okay? Depending on its value. And we have here the following values of n. Okay? So first one, if the value of n is equal to 0, we call this process an isobaric process, meaning that is a constant pressure process. Okay? Isobaric is a constant pressure process. Okay? The value of n for that is 0. Okay? So, kapag naman po yung value ng n is infinity or infinite, okay, we call the process as isometric or isovolumic. It could be also isochoric. Ibig sabihin, that is what we call the constant volume process po. Okay? And then, kapag naman ang value ng n is equal to 1, we call this process as isothermal. Ibig sabihin, that is a constant temperature process. Okay? And then, kapag yung value naman ni n is equal to k, therefore, this process is called adiabatic or isentropic. Okay? Ibig sabihin, constant entropy process. And recalling the adiabatic process, okay, we can say that, ibig sabihin po ng adiabatic, again, recall lang natin, ibig sabihin there is no heat transfer. Kaya nakalagay dyan, Q is equal to 0. Okay, since there is no heat present or there is no heat transfer. Okay po tayo doon. Okay, and then, sabi dyan, constant entropy kaya S is constant. Okay? Then lastly, if the value of n is not equal to k, we call this polytropic or multiple expansion and compression. Okay po tayo doon? Are we clear on that? Okay. So, raise your hand lang po kung meron kayong tanong. Okay? Okay. So let us proceed na agad po with the first ideal gas process, which is what we call the isobaric process. Okay? So isobaric process is again a thermodynamic process taking place at constant pressure. Okay? Isobaric, constant pressure, the value of n is equal to 0. Okay? So brief history lang, the term isobaric. has been derived from the Greek words iso and baros. Okay? Ibig sabihin po, equal pressure. Okay? Isobaros. Equal pressure. Kaya dun siguro nanggaling yung term na isobaric. Okay? Yan. At such, the constant pressure is obtained when the volume is expanded or contracted. All right? Yan. So we have here an image or an image of a uh, piston cylinder device, and you also have here a PV diagram. Okay? Sabi dito, at constant pressure, the mass maintains a constant pressure in the cylinder. Okay? So ibig sabihin lang naman diyan, okay po, ano, as the okay, at constant pressure, no, at an isobaric process appears on PV diagram as horizontal line. So ito po ay itsura, okay, ng isobaric process sa PV diagram po. Okay, a horizontal line, a simple horizontal line. Okay, so as the value or as the as the gas, okay, as the gas expands, the volume increases. Okay? And from state point 1 to 2. Or uh, the volume goes to the right po. Okay? Yan. So we have here the 7 general equations that can be related to the process as follows. Okay? So for here, you have to understand bakit po ba sir kailangan pa namin pag-aralan yung derivation. Okay? And we have here 5 processes. Okay, we have 5 processes and we have 7 general equations. Okay, and that means, okay, 7 general equations and then you have 5 processes. Multiplying 5 by 7, we have 35 equations. Okay, most probably po ay ganun din kadami. Actually, more than that if I'm not mistaken. Okay, so more than 30 na lang ang sabihin natin for you not uh, um, to memorize it all, those 30 equations. If you know how to derive, you can easily, okay? You can easily derive the equations by just knowing simply the what? The 7 general equations as well as the value of n. Okay? And everything that you have gained knowledge from chapters 1 to 3. Okay tayo doon? Alright. So in that case, okay, let's just derive. Okay, mag-derive po tayo dito. So here are the 7 general equations relating to isobaric process. Okay, so when we are deriving, okay, we always start with the first one, which is the PVT relations. Okay, so 1, okay, PVT relations. Okay. So first thing first, okay, since this is at constant, this is isobaric process, we all know the V over T is equal to C. Okay, which can be also written as V1 over T1 is equal to V2 over T2. Okay, which is equal to V1 over V2. Okay, cross multiplying lang po. Then T1 is equal to T2. Okay, this one and this one are just the same. Okay po. Alright, so please take note again to use the absolute temperature. Okay po. So, syempre, kapag ang given naman po yung absolute temperature na, di you use at it is po. Okay? Pero kung yan po ay hindi naka-absolute temperature, kahit yan po ay makakancel lang, you still have to make sure na tama ang sagot natin, you still have to convert it into absolute temperature. Nagkakaintindihan po tayo doon? Alright. So, next one for the 7, sorry, 3 agad. 2. Okay? Is the work done flow. Okay, hindi pa na. Ilagay ko na lang yung symbol ni work done flow, which is Wn or W subscript n. Okay, so from its general equation na Wn is equal to integral ng PdV, okay, from 1 to 2, Okay? So, again, from its process definition, okay, where PV, okay, PV is equal to raised to n is equal to C, where n is equal to 0, which implies an isobaric process, we can say that P V raised to 0 is equal to C, anything raised to 0 is equal to 1, which will give us pressure is constant. Okay? Yan. From there, substituting the value of P, okay, from the integral equation, okay, we have here Wn, okay, Wn is equal to P delta V. Okay? Which will give us an equation of P is equal to V2 minus V1. Okay? Which is also equal to P1, or P2 rather, P2 V2 minus P1 V1. Okay? So this P delta V is also equal to an ideal gas law equation, which is PV is equal to mR delta T. Okay? mR delta T. Can you still recall? Okay. So, which is also equal to mR T2 minus T1. Okay? So, 2 means final and 1 means the initial. Okay? Yan. Alright po. So, that's how you derive. So, these three equations po, okay, these three equations can be used in solving the work non-flow for under isobaric process. Nagkakaintindihan po tayo? Alright. And then, we also have for work steady flow under isobaric process. Okay? Work steady flow, or WS. For this one naman po, okay, the equation WS is equal to negative VdP, okay, from 1 to 2. Okay, so for work steady flow po, since this is a constant pressure process, we assume that P is equal to C. Okay, therefore po, ang differential of pressure or dP will also be equal to 0. Okay, so in that case po, it will just simply give us a 0 value. Okay, or a 0. Okay po, therefore, ang ating pong work steady flow kapag tinanong sa problem, what is the work steady flow under isobaric process, we'll just simply answer 0. Nagkakaintindihan po tayo? No, still, kahit po yan ay 0, it can still be asked. Okay? It still can be asked po sa problem. And the answer is just simply equal to 0. Okay po? Alright. And then, we also have for heat. Okay, heat or, for heat or Q. Okay, for heat, we have the equation. Heat is equal to delta U plus the Wn, or delta PV. Delta U plus delta PV. Okay, or yan, P delta V. Okay? Since constant pressure po ito. Okay? So, in that case po, if we're going to substitute the equations for delta U, which is mCV delta T, okay? Delta T plus Wn is equal to PV, which will give us P delta T. Okay, that will give us, which is also equal to P delta T is equal to MRT. So, plus MR delta T. Okay. In that case, pwede nating, since magsisame lang naman yan, we can put out the M at saka delta T. Plus, pwede nating CV plus R. Okay, which is equal to CV plus R, if you can still recall from the properties of ideal gas is equal to Cp. Therefore, ang ating pong heat is equal to mCp delta T. Okay po tayo doon? Okay? So, wait lang. Lagyan pala natin ng underline yung mga equations. Okay, yan. Okay, ito, ito, ito. Okay, and this one, this is not an equation, pero yes po, pwede natin yung isagot. Okay, pwede rin natin to, ito, this one, ito na mismo. Okay, yan. Okay, yan. And then, that is for heat po. Again, heat is equal to mCp delta T. We also have here for internal energy. Okay? For internal energy under isobaric process, okay, internal energy U, for internal energy U, just simply use, again, the delta U, okay, is equal to mCv delta T. Okay, again, delta T is equal to T2 minus T1. Okay, for enthalpy naman, okay, for enthalpy, underline lang natin, we'll just simply state that the equation for the delta H is equal to mCp delta, internal energy mCv delta T. And then we also have here for internal energy, enthalpy rather, okay, number 6, enthalpy or H. Okay, for H naman, okay, enthalpy mCp. Okay, yan. Whereas, pwede natin sabihin dito, okay, under this process po, under isobaric process, heat transferred or the equation of heat is also equal to the change in enthalpy. Therefore, pwede natin sabihin ito, delta H, okay, is equal to heat. Therefore, ang ating pong equation for enthalpy, okay, enthalpy, delta H is equal to mCp delta T. Okay? Underline natin. And then lastly, we have here, sana magkasya, we have here the entropy S. Okay? For entropy S from its equation, okay, from its equation, and, equation S is equal to the integral of dq over t, okay, from 1 to 2. Okay, so we all know that dq is equal to mCp delta t from here, okay, from there. No? So in that case po, will give us dq as mCp delta t. Since we are given there t, pwede nating ilabas si mCp. Okay. Okay. Alright, so labas natin sa mCp. mCp. Okay, integral ni dt over t from 1 to 2. Okay, so ang integral ng dt over t is ln. Okay, ln na t2 over t1. Okay, therefore, ang equation ng entropy natin is equal to m, mCp ln na t2 over t1 po. And then, evaluating, okay, and using the PVT relations above, we can also say that entropy is also equal to ilagay na lang natin dito. Babain pa natin ng konti para yan. S is also equal to mCp ln ng T2 over T1. Okay? Or can be also equal to mCp ln V2 over V1. Okay? Pasensya na shortcut ng konti. Ni sir ang pagdiderive. Yan. But this two is the equations. Okay? So imagine sa one process pa lang, we can have a 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, isama na natin to for you to remember. 10 equations already. Okay? So, imagine kung 10 yan, so probably ganyan din yung iba. Okay po. So, for you to easily understand the different processes. Or for you not to memorize it all, you can simply derive during examinations. Okay? Pero syempre, again, hindi ko naman kayo pinipigilan mag-derive, mag-memorize. Okay? Again, but still, in your exam, one process will be derived. Okay? Will be derived in your exam. Okay, tayo doon? Alright. Yan. So, this one is for the isobaric process. Okay? So, do you have questions so far? Okay. So, let us proceed in answering this example problem number 1. Okay? So, for example, problem number 1, stated there, a certain gas with Cp is equal to 0.529 BTU per pound mass Rankine, and a gas constant is equal to 96.2 pound force feet over pound mass Rankine. Expands from 5 cubic feet in 80-degree Fahrenheit to 15 cubic feet while the pressure remains constant at 15.5 psia. Compute A is T2 or final temperature, B delta H, okay, or enthalpy in pound force feet, and then C internal energy in BTU, and D entropy, okay, entropy S in BTU per Rankine, and then lastly for internally reversible non-flow process, what is the work in BTU? Okay, yan. So, first thing first, again, I want you to write down the, okay, write down the given, right? So, for given, okay, always write down the given po. Okay, so let me just take a snip na lang nito so that hindi na natin pahabain yung mga oras. Para hindi humaba yung oras natin sa pagsusulat. Okay, so we have here the values that are given. Yan. So we have here CP, okay, the 0.529. We also have here R, 96.2, volume na 5 cubic feet. We have here the initial temperature, 80-degree Fahrenheit. V2 is equal to 15 feet cubic feet. And then we have here, since in the isobaric process, you can say that pressure is equal to 15 psi. Okay, ibig sabihin, guys, yung PSIA is just simply indicates that the pressure given is an absolute pressure. Okay? So again, this is an absolute constant pressure process problem. Therefore, we're going to use the VT. Okay? VT is equal to C. Okay? So, but first, let's write down first the things that are being asked. So, the things we need to find here is the following. Okay? A, sige, wag na natin isulat. Isulat na natin dito. Okay? So the following, okay, hindi na isusulat ni sir, but we have here A, B, C, D, E. If we are tasked to find, okay, the following that is written here already. Okay? So first one, solution. Okay? But always, makikilagay po ko ha, solution for letter A. Okay? Ayan. Sabi, solve for the final temperature. Okay? Again, since this is an isobaric process, okay, we're going to use equation V1. Okay? V1 is equal to V2 is equal to T1 over T2. Okay? So you can also use the V1 over T1 is equal to V2 over T2. Okay? You can also use that equation po. But since ang pinapahanap naman sa atin dito ay itong T2, so just simply arrange the equation from this equation to T2 is equal to V5 T1. Okay, T1 is equal T1 V2 times V2 is equal to V1. Okay, so T2 therefore, okay, is equal to Oh, by the way, ang pinapahanap diyan, T2, walang sinabi kung ang pinapahanap po. Again, ang gagamitin niyo kapag nagso-solve is absolute temperature. Pero pwede po maging sagot ay hindi naka-absolute temperature. Therefore, katulad po ng case na 'to, okay, maminusan niyo ng 460. Okay? So, in this case, walang sinabi, but since tatandaan niyo kapag walang sinabi, titingnan niyo yung given. Okay? Katulad dito, walang sinabi kung ang temperature na kinukuha ay ang kukuhanin mo ay in degree Fahrenheit or Rankine. Pero sa given, ang given po na temperature or initial temperature is in degree Fahrenheit. Therefore, the resulting value of the T2 must also be in degree Fahrenheit. Okay po tayo doon? Right. So T2, the value of T1 is 80 degree. Okay, 80 degree plus 460. Okay, para maging Rankine po. Okay. And then we also have here V2, which is 15, okay, 15 cubic feet. And then we also have here, ano po, we have the volume 1, which is equal to 5 cubic feet. Yeah. Okay. All right. So in this case, the answer would be 80 plus 460 times 15. Okay. And then divide by 5. The answer is 100. Okay, cancel muna po na natin to. Then the answer would be the T2 is equal to 1,000 rather, 1,620 Rankine. Since again, the given is in degree Fahrenheit, we also have to make the T2 in degree Fahrenheit. Therefore, subtracting 460, therefore, T2 is equal to minus 460. That will give us 1,000, okay? 1,160 degree Fahrenheit. Alright po. Therefore, that is the answer for T2. Okay? Yan. So, i-box lang natin. Saan ang box dito? Ito. Ay, joke. Ito pala. Okay, the answer is this one. Yan. Okay. Okay? Alright. And then, ang sabi, so meron na tayo for A. That's fine for B. B. Sabi po dyan is find the enthalpy in pound force speed. Okay, so for letter B, okay, so we all know the equation for delta H or enthalpy is mCp delta T. Okay, delta H is equal to mCp delta T or T2 minus T1. We already have a given here that meron na tayong yan. So the equation mCp delta T. However, okay, wala pa tayong mass po. Okay? Wala pa po tayong mass na given dito. Okay? So therefore, kailangan pa nating hanapin. Okay? Ang value ng mass. So sir, alin po ang gagamitin? Okay? Sabi po ay pwede nating kunin. Okay? Using ang M, using the equation ng PV is equal to MRT. Okay? So from that equation, okay, makukuha natin for M, okay, for mass. So kunin muna natin si mass from PV is equal to MRT. Okay? Then, ang gagamitin po natin dyan is the one for initial. Okay? Initial values. Therefore, M is equal to P1 D1 over R T1. Yan. Which will give us a Pressure 1 is 15.5. Okay, PSI. Ano natin para sure. Pound force, inch, square inch. And then ang volume natin is 5 cubic feet. So since ito ay naka-inches of cubic feet, then kailangan natin i-maging pound force. Therefore, i-ano muna natin, convert na yung inch, square inch into 1 cubic feet. Okay? And then 5 cubic feet. Okay? And then we have their value ng R, which is 96.2. 6.2 pound force. Feet. Then we have here pound mass. Mankind. And then T1, which is 80 plus 460. That will give us runtime. Okay. Unit analysis muna tayo, guys. So, cancel, inch square, pound force. Magiging ano tayo, ang pinapalit sa atin yung pound force. So, cubic feet, matatanggal. So, if-it pa ng isa. Okay. And then we have here PSI. Ang PSI is equal to pound force, tama. Runtime, makakancel. Alright. And then, meron tayo dito pound force. Okay. Pound force. Pressure. Pound force. Yeah. Pressure is equal to force over area. Runtime. And then, we also have here runtime. Consent. Pound mass at saka pound feet force. Okay. Yeah. Tama. Kasi ang hinahanap natin dito ay mass pa. Okay. Yeah. And then, meron pa tayo dito isang feet. So, ipakancel lang din to. And then, the resulting value would be mass. Therefore, the value of mass is 5 point, sorry, 5.5, 15.5, sorry. 15.5 times 144 times 5 times 5 over 96.2 times 80 plus 80 plus 460 will give us equation of 0.2184. Okay? Therefore, ang mass po natin, okay, ang mass natin is equal to 0.2148302,148 pound mass. Therefore, pwede na nating i-obtain ang enthalpy po natin. Okay? So, our enthalpy, okay, enthalpy that will give us P1, sorry, M, which is 0.214. Okay, 8. Please use the whole value to putulin ko lang dito kasi hindi magkakasya. And then CP na 0.529 BTU. Mass per runtime. And then T2 minus T1. T2, ang T2 po natin ay 1,060. Okay. 1,060 minus 80. 350 Fahrenheit. Okay. And then, tingnan natin. Iyan ako muna. Store ko to. Times 509 times 160 minus 80. So, alright. Yan. So, i-cancel out muna natin yung mga equations. Unit analysis muna tayo. Cancel si pound mass, pound mass. By the way, this degree Fahrenheit is also equal to, yan, Rankine na ha. That is simply equal to Rankine 2. So, dito po, since we're dealing with temperature difference, okay, that 2 is already, or that 2 are already in absolute temperature rating. Okay, therefore, 1 degree Fahrenheit is equal to 1 Rankine. Okay? Yeah. So, this will give us an resulting value ng delta H. Sorry, hindi ko na nasulat yung delta H. Ito, delta H is equal to 122, okay? 122.736.7983. Okay? That is still in BTU. Therefore, sabi dyan ay in pound force feet. Okay? That will give multiply by 778. Okay? Pound force feet all over 1 BT. Okay? So, the answer times 778 times 778, that will give us a result ng enthalpy na equal to 95,489,22909 pound force feet. Okay? So that is the answer for letter B. Yan. Okay? Gandahan po yun. Alright. Gandahan po tayo. Okay. So, diretso lang natin. Part. Okay. So, diretso lang po natin. Okay. Start ko lang po. Yan. So, sabi naman is the internal energy. Continuation lang tayo ha. Continuation. For letter C, or ang pinapanap dito ay internal energy in BTU. Okay? Internal energy, recall the equation of internal energy. Delta U is equal to mCV delta T. Okay po? mCV delta T. Okay? So, since wala tayong given na CV, but we have given na CP at saka R, we can obtain the equation for, or we can obtain the value for CV by simply using the from CP, okay? CP is equal to CV minus plus R. Therefore, CV is equal to CP minus R. Okay? Therefore, we're, okay, so, nalagay nyo lang, where CV is equal to CP minus R. Okay? Ang given ng CP natin is 0.529 BTU. Okay? Mass Rankine minus R. Okay? Minus R na 96.2 pound force feet over pound mass Rankine. Okay? Yeah. So, unit analysis muna. Kailangan natin itong i-convert. Ano? Yun, kailangan ba? Yeah, convert muna natin yung pound force. Ito, convert natin into 778 pound force feet. Okay, ito 1 BTU para makancel natin. Okay, so ito cancel ito. Cancel yung cancel ba? 778 BTU. Yeah, hindi siya kailangan makancel. Yeah. And then, kasi kailangan lang is magiging, ang unit nito ay BTU per pound mass. Okay. Yeah. Okay, so pag mamay nasunod pa. So, 0.529 minus 96.2 divided by 778. Okay? That will give us a value of, ang CB po natin, okay, the value of CB, therefore, ano, no, 3. Okay, the value of CB is equal to 0.405396144. Okay, that will give us BTU. Okay, mass runtime. Okay, so since meron na tayong CB, pwede natin i-solve. Okay, delta U is equal to yung mass natin kanina, okay, na equal to lang. Magbubuksan pa ba natin yun? Time, open, okay, D, yan. Yan. Ang value natin ng mass is, batang natin, store ko lang. Ang mass natin ay 2.2148302.148. Store. Okay. Open lang ulit natin. And so, ating mass is equal to C, which is, okay. Hindi ko na diretso dito. Hapat, please, huwag niyo kakato pag kayo nagsusot. 2148 pound mass. What I'm going to use sa calculator ko po, ay yung buo ha. Okay, and then 0.45405.3, blah, blah, blah. Okay, para lang po hindi mga ito. And then, we also have here yung temperature po natin. Okay, degree Fahrenheit. Okay po, again, which is itong degree Fahrenheit na to equal. Okay, wait, run kayo. So, cancel, cancel, cancel. Will give us an equation of, okay, so, 116 minus 8 will give us 94. Okay, therefore, ang ating delta U is equal to 94.04785231 BT. Okay, yan po ang sagot sa letter C. Okay po. And then, for letter D. Diyan. For letter D, we have here find for entropy or delta S. Okay? So from the equation, okay, uh, delta S, okay, delta S, sabi nga po, pwede natin makuha ang delta S using MCP. Since ang given sa atin dito ay we're given here T2 and T1, pwede natin gamitin yung MCP ln T2 over T1. Okay? So from there, meron na tayong mga values ng mass. Okay? Ang mass natin ay 2. Okay, gamitin nyo yung true values. Okay? 2, 1, 4, 8, so on. Pound mass. Meron tayong given na CP na 0.529 BTU per pound mass. Unkind. Okay. And then, and we have here ln, okay? Ng, this one, kailangan nyo munang i-convert into absolute temperature reading. Sorry. Okay, so 160, 20R, at saka 540. Okay, so parehas lang yung temperature 1 and 2 natin. Dinagdagan ng 460. Okay, ayan. So, unit analysis muna tayo. Pound mass, makakancel. Runtime dito, makakancel to. So, ibig sabihin hindi makakancel to. Runtime na to. Okay, cancel this one first. Then, since ito unitless na, hindi na to makakancel. Okay, therefore, okay, multiply lang natin 529 times ln, okay, ng 1620 over 540. Okay, so the answer for delta S for entropy is equal to 0.12485199953 BTU over runtime point. Okay, so that is the answer for that 30. Okay, and then lastly, okay, E. Ang pinapahanap po dyan, ang sabi lang po dyan, huwag malilito ha, medyo humaba lang yung pinapatanong dyan. For an internally reversible non-flow process, what is the work in BTO? Ano? Okay, or what is the work non-flow? Malilito po doon. Okay, so for work non-flow, okay, so always check the parameters na meron na kayo. Dito, in this case, pwede natin gamitin is dP delta PV. Okay? Or Wn is equal to P delta V, rather. Okay? So, P V2 minus V1. Okay? So, in that case, and just simply substitute the values over m squared. Tapos, convert nyo lang ulit to 144 m squared over 1 cubic feet. Square feet pala. Times, meron tayong V2 na 15 minus 5. Okay? Cubic feet. Okay? So, I think kung unit analysis muna. So, cubic plus tira pa dito, feet. Okay? So, the resulting value will be in pound force feet. Okay? So, multiply muna. 15.5 times 144 times 15 minus 5, 10. So the answer in pound of force is WN is equal to 22,320 pound force feet. Then, kailangan po ay in BTU, so multiply lang natin sa ng or divide. Okay, divide na po natin ang ano ha, kasi 1 BTU is equal to 778. So, pwede na natin i-divide na lang siya, okay, ng pound force. Pero, yan. Pwede rin naman po yan. Pwede rin, hindi lang kasya na dito. Pero pwede nyo yung i-multiply by 1 over 778. Okay? Which is equal to, and divide 778. Okay? Which is equal to, work non-flow po natin, lagay na lang natin dito ha. Work non-flow is equal to 28,688,94 602 BT. Okay? Nakakaintindihan tayo doon? Yan. Right? So yun. That's how you solve an isobaric process problem. Okay? Or a problem under isobaric process. So, ayun, since syempre kita naman natin yung mga ginawang way. Okay? So, mostly ganito lang din yung way ng pagsosolve nyo. Okay? So, again, it's time for you to memorize the following equations, okay po, under isobaric process. So, as you can see naman, mostly or frequently used na mga conversion of units dito is yung 12 inches is equal to 1 foot. Okay? Yung 1 BTU is equal to 778 pounds per feet. But still, okay, pwede pa natin yung i-convert into other units. Okay po, so you have to recall also the conversion of units for energy, for power. Okay? Yan. Okay tayo doon? Nagkakaintindihan tayo everyone. So, syempre, again, as per your assignment, you re-evaluate problem number 2. Kakaintindihan po tayo doon? Alright. So, as you can see here naman dito, kung nakikita po, again ninyo dito, ginamit ko is mga true values. So, sa exam nyo, just in case, mabunot itong problem na to, pumunta siya sa inyong problem, or I mean, lumabas siya sa problem solving question. Okay? So, kapag po hindi po naka-true values, the way I presented it to you, I won't accept po the answers. Okay po, kasi ibig sabihin, wala, since sa ulo lang. Okay? Pinagbigyan ko lang po kayo sa midterm exam, meron pong ganong cases. But this time po, you have to show me how you really did it. Kasi sometimes, hindi naman, or based on my observation, for sure, dahil nasa ulo lang ng bata. Yung pong answer. Magkakaintindihan po tayo? Okay. Ano? So, most probably, yung gawin ko dun, hindi exact na exact this time. Okay? Hindi na po exact na exact yung atin pong problem from the book. Ano? So, may babaguhin si Sir na given. No, hint na yun, ha? Okay? From the book, pero magkaiba na ng given. Okay? So, you really have to study po. Okay po? Alright, so, ayun po. Do you have questions so far? Before we proceed? Okay, so I guess none. Okay po. Question po. Baka po kayo ay may question. Question guys? Baka po may tanong kayo? May tanong po ba? Process. So we are done with isobaric, meaning a constant pressure process. So this time naman po, we'll be dealing with isometric. Okay, so isometric process. Okay, isometric process is a thermodynamic process taking place at constant volume, which is known as the isometric process. Okay, so V is constant, okay, or volume is constant. It can be also called as an isochoric process, okay, or constant volume process. Okay, double check. So, yan. So the term isochoric has been derived from the Greek words iso, meaning constant or equal, and then choric meaning space or volume. So together, they are constant volume or equal space or equal volume. Okay? So from a PV diagram, so this it looks like po sa PV diagram kapag naka-plot si isometric process. Okay po? So it shows an vertical line. Okay? Kung compare dun sa ating isobaric process, we have a horizontal line. This one naman po is a vertical line in a PV diagram. Okay? So for an isochoric process, the area under the PV curve is 0. Okay? So ibig sabihin, there's no work done. Alright? So here are the 7 general equations, or that's under 7 general equations can be related to the process as follows. So again, let's always start with the PVT relations. Okay? So for PVT relations, we have here first one is the PVT relations. Okay? Since dito po tayo again is volume is constant, therefore we'll have the equation P over T is equal to C. Okay, which is simply equal to P1 over T1, okay, equal to P2 over T2. Okay, again, this equation is simply equal also to P1 over P2, okay, by cross multiplying T1 over T2. Okay, so again, kung gusto nyo man po yung mabaliktad itong
naging T2 over P1. Make sure lang din na yung babalik na rin nyo lang din po itong T2 over T1. Okay? So this one and this one, they're just the same. Alright? Okay. So let's proceed na agad with work done flow. Okay? Or gamitin ko na lang yung symbol ng work done flow, which is W subscript N. Right? So from the equation, okay, equation Wn is equal to the integral ng PdV from 2, right? No, so po ay constant volume, okay? Therefore po, ang ating dV here is equal to 0. Okay? Which simply means kapag ating pong in-evaluate, will just simply give us a value of 0. Therefore po, ang work non-flow under isometric pressure, isometric process is 0. Okay? Still, okay, ito po yung mga equations, possible equations natin. And so, okay. So, please take note na even 0 si isometric, 0 si work non-flow under isometric process, still, okay, it can be asked sa problem po or sa problem solving. Okay po, so please take note of that. Okay, so if ever man na yun ang tanong sa problem, all you have to write is 0. Okay, that will be the value of work non-flow under isometric process. Okay, moving on, we also have here work steady flow or W subscript S. Okay, so yeah. So for work steady flow naman for steady flow work, okay, we have the equation Ws is equal to negative integral, okay, of V, oops, sorry, VdP, okay, from point 1 to 2 po. Okay, so whereas we all know, okay, that PV raised to N is equal to C, okay, where N is equal to infinity or infinite, okay, which implies constant volume. From this, we can say that volume is equal to C or volume is constant, okay? So in that case, we're going to substitute the value of V, which is C muna, okay? So it will give us negative, labas na natin since C, constant siya. So labas na natin integral ng dp from point 1 to 2. Okay, so from there, integrating dp will have the negative c. Integral ng dp is from point 2 to point 1 to 2 will have pressure 2 minus pressure 1. Okay, therefore, we can say that the equation of work steady flow under isometric process can be, okay, substituting the value of C, which is V or volume, will have negative V is equal to, times, rather, P2 minus P1. Alright? Kaintindihan po. Which is, pwede rin po natin siyang baguhin. Again, this is just the same. Ipinasok lang natin or dinistribute lang natin yung negative sign. Therefore, it can also be written as V times the P1 minus P2. Okay, so dinis lang po yung negative sign. Okay, or ni-rearrange lang. Right, para matanggal yung negative sign. So, ibig sabihin, that could be the equation for work steady flow under isometric process. Okay, and then we also have here for heat. Okay, for heat. For tayo, heat. Ayan. Heat. Sa heat naman po, from the general equation, Q is equal to delta U, okay, plus Wn. Okay? Alright, so from the equation, delta U, alam natin ang delta U is, ano nga, M, CV, delta T. Ano? So, hindi nyo na makakalimutan yan, ano? And then, we also know that under the value of work non-flow, okay, under isometric processes, 0. Therefore, the equation for heat under isometric process is mCv delta T. Okay? Where delta T is equal to T2 minus T1 or the final temperature minus the initial temperature. Okay? And therefore, we can say that ang heat po natin dito, please take note, ang heat natin is equal to internal energy. Alright? Okay? Ano? So, ayun po. That is for our heat. Okay? That is the equation ng heat under ng isometric process. Okay? So, we have here internal energy. Okay? Internal energy or U. Okay? For internal energy, we have here the equation. Okay? The equation for internal energy na delta U, sorry, delta U is equal to, ano, namang ganun. Are you still recording? I don't think it's recording pa. Then, ayan, recording in progress pa daw siya. Alright, so let's just continue. Again, for internal energy, we have here delta U is equal to mCV delta T. Okay, and then for enthalpy, nagcha-choppy audio ko. Siguro dahil lang ng internet dito sa school. Okay, so pasensya na for that. Sige. Okay, how about this time? Okay naman yung audio ni sir? Medyo nagpa-fluctuate kasi yung internet ni sir at the moment sa university. Okay? No, pasensya na. Okay, so let me know na lang ulit. Sige, chat lang kayo if ever. Okay, so we have here second to the last, which is the enthalpy. Okay, enthalpy H. Okay, in that case po, enthalpy can be obtained using the equation delta H. Okay, delta H is equal to mCp delta T. Okay, ayan. And then that's it. That's already the equation for enthalpy. Okay, kasi again nga dyan, the equation of enthalpy in any process will always be that delta H is equal to mCp delta T. Okay? And then lastly, we have for entropy. Okay? Entropy S. Okay? Entropy, okay, in that case po, no, from its general equation is equal to the integral of dq over t from state point 1 to 2. Okay, whereas we all know that dq is equal to mcv delta t, okay, which will give us an equation of mcv, okay, or delta t, yun na yan. Okay, so substituting the value of dq, okay, we have here mcv integral ng dt over t. Okay? So, therefore, pwede natin integrate. So, ang meron tayo dyan is ang integral, again, ng dt over t is ln, okay? ln t, ng t2 over t1. Okay po? No, which is also equal to, based sa PVT relation, is equal to mCv ln ng P2 over P1. Okay po tayo doon? Yan, underline ka lang yung mga equations dito. Yan. Okay, so kung kanina 1, 2, 3, 4, 5, 6, 7, 8, 9. O dito sa ating isometric process, 9 equations. So minus 1 kasi 0 naman yung work non-flow. You have to remember 8 equations under isometric process. Okay? Nakaintindihan tayo? Do you have questions so far? Class, do you have questions so far? None naman. Okay. So that is the equations under isometric process utilizing the 7 general equations. All right. So let's proceed with the problem solving number 1. Okay. And problem solving number 1 or example problem number 1. Okay. So problem number 1 says 10 cubic feet of air at 300 PSIA and 400 degree Fahrenheit is cooled to 140 degree Fahrenheit at constant volume. What are A, the final pressure in mmHg, B, the work, okay, C, the change of internal energy in BTU, D, the transferred heat or the heat transferred in pound force feet, E, the change of enthalpy in BTU, and F, the change of entropy in pound force feet Rankine. Okay, so first thing first, always remember to write down the given po. Okay? So the given are the following. Right? So still, you have to include kung ano yung pinapahanap ha. Okay? Hindi man maisama ni sir dito, hindi ko na isusulat. Pero please, lalagay pa rin po yung mga pinapahanap po sa ating pong problem. Okay? So we have there ilan dyan? A, B, C, D, E, F. We have 6, okay, missing parameters or pinapahanap sa atin. We are tasked to find 6 parameters. All right? Okay? So yan. So after writing down what is being asked for us to find, so let's start solving. Okay? So solution, so write down your solution. Sana magkasya to sa isa. Okay? So for A, sabi dyan, okay, what are the final pressure? Final pressure, so ibig sabihin P2. Okay? What is P2? Yan. So from the equation, okay, since using the PVT relation at constant pressure process, we have here P1, okay, P1 over T1, right? Is equal to P2 over T2. Okay, so since ang pinapahanap sa atin ay T2, okay, we can rearrange the equation. Okay, from there we have T2 is equal to P1, P1, ay sorry, ang pinapahanap ay P2 pala, hindi po T2. Sorry, pinapahanap po ay P2. Okay, so P2 ang pinapahanap, rearrange lang natin, so that will give us P2 is equal to P1 times T2 all over T1. Tama? Alright, tama. Okay, so substituting the values given, okay, we have here 300 PSI. Sabi dyan, final pressure in mmHgs. Therefore, we can convert this PSI to mmHg. We have the value naman na 14.7 PSI. Okay, 4.7 PSI is equal to 760 mmHg. Okay, which is also written po sa ating module, itong conversion of unit na to. Okay, and so cancel lang. And then we also have here the, sabi ko nga sa inyo, the temperature that you must have here is in absolute temperature. Therefore, given nating T2 is 400 degree Fahrenheit, dadagdagan po yan natin ng 460. Alright? Then that would become Rankine na po. Okay? And then, next natin is over T1. Okay? Sorry, 140 pala. 140 ang ating T2. Sorry for that. 140 plus 460. It will give us Rankine. Okay? And then, we have here T2, which is equal to T1 rather, 400 plus 460. Okay? So, ating nga pong i-calculate. Okay, nasaan ang calculator niyo, sir? Ayun lang, wala tayong dalang calculator. I'll try to use calculators. I'll try to use my calculator dito sa phone. 300 Oops, sorry. So that is 300 times 760 divide 14.7 and then times, okay, 140 plus 460, okay, all over 860. Napakadami namang decimal points nito. Okay, para gamit ang calculator. 300 times 760 over 14.7 times 140 plus 460 divide 400 plus 460. Alright. Okay, bakit mali? Mali ako. Bakit 23,000 ang sagot ko? Okay, sorry. For what? 400. Ay, 400. Ay, sorry. 300. 300 times 760 over 14.7 and then 140 plus 460 and then 400 plus 460. Ayun, tama. 10.82. Okay, so canceling. Okay. Did you yield the same answer, guys? Are you using your calculator po? Okay, so good. Okay, therefore, ang ating po final pressure, okay, the value of our final pressure is equal to 10,821, 0.7262 mm Hg. Tama po ba? Yun din po ang nakuha niyong answer? Okay, good. So I do hope everyone is using their calculator. Okay? Continuing. Okay, so for letter B, meron na tayong A. Sabi, yan no, di ba? Meron pa rin pinapahanap ang work. Okay, sabi, di ba po, sabi natin kanina sa lecture, in isometric process, there is no work being done. Okay, ang tanong for letter B, okay, ang pinapatanong ay work. Okay, work. Okay, which is will fall under work non-flow. Okay, so in that case po, we can just simply state that since this is an isobaric process, okay, i-state nyo dyan, since at isobaric process or volume is equal to, therefore, Wn is equal to 0. Nakakaintindihan tayo dun, guys? Okay tayo dun? Alright. And then, for easy as that. Okay. So, letter C. For letter C, we have here solve for the internal energy in BTU or change of internal energy. Okay. For internal energy, using the equation, okay, delta U. Delta U is equal to mCV delta T. Okay? Tama po ba yun? Yan. Okay? So, in that case po, alright, please take note also na ang pinapahanap sa atin dito or ang ating working substance is air. Okay? So, ilalagay nyo din pala yun sa given, ha? Yan, air. Air, then volume 1, P1, T1, T2. Okay? Para mas madali nyo ma-distinguish yung other given. Okay? Kasi, other parameters. Okay? So, ibig sabihin, kapag air, we have already, or you are given already different properties of air. Okay? Kaya sabi ko sa inyo, kailangan natin sauluhin yun. Okay? Natatandaan pa na binigyan ko kayo, or dyan sa module meron, na properties of air. Tanda pa po yun. Under specific heat, okay? Under specific heat, gas constant, at saka specific heat ratio. Tanda pa po yun? Natandaan pa? Okay, so in this case po, we have here values of CV for air. Okay, ilagay natin dito. Ang CV ng air, okay, ang CV ng air is equal to 0.171 BTU per pound mass runtime. Okay? But unfortunately, wala pa tayong mass po. Okay? Therefore, we're going to obtain the value of mass. Okay? Where M can be obtained using the equation from using the equation PV is equal to MRT. Since we have here given na pressure 1, volume 1, we also have the value of T1. Ano? And then ang R po, okay? R for air is 53.3 pound force feet over pound mass per runtime. Okay? So from there, where M is equal to P1 times V1 all over R ng air times T1. Okay? Where R ng air, okay, recalling the constant value of the gas constant of air. Okay? We have here 53.3 pound force feet all over pound mass runtime. Nagkakaintindihan po. Therefore, substituting all the values, we have here 300 PSI or i-ano na natin, pound per square inch. All right? Okay, that is pound force since yan ay pressure. And then we have here V1, okay, na by the way, since ang kailangan dito ay pound mass, and then para makancel natin yung inch squared A, convert natin into 144, okay, inch squared over 1 square feet. Okay, times the volume na 10 cubic feet. All right. Then all over R, which is 53.3 pound force feet all over pound mass runtime. Okay. And then we have here T1, which is 400. Then since kailangan din naka-absolute reading, okay, therefore add natin ng 460 para maging runtime. Okay, unit analysis muna tayo guys. Cancel this out. And then may matitira pa dito feet na isa. Yung pound force, pwede natin i-cancel. And then yung natitirang feet, pwede na rin natin i-cancel. Runtime, okay, pwede na natin i-cancel. Therefore, all right, the resulting value uh, 300 times 144 times 10 all over 53.3 times 400 plus 460. The answer is 942449491. Yun din po ba ang sagot natin for mass? Did you yield the same answer po? 9.4249491 pound mass po. Okay, since ito na lang yung natira nating unit po. Okay, and then ang kailangan natin is mass. Okay, so substituting the value, therefore, delta U natin is equal to mass, which is 9.4244. Okay, hindi lang ilalagay ni sir lahat, pero gagamitin pa rin yung lahat. I-store ko lang. Okay, yan. Times, ang delta U natin ay kailangan ay in BTU. Okay, so pound mass, 9 mass. Ang CV natin is 0.171 BTU per pound mass runtime. And then we have delta T. Okay, ang delta T natin ay equal na po. Ito po ay, since ito ay temperature difference, we're going to just simply leave it like that po, which will give us 140, okay, 140 minus 400. Okay? Okay? T2 minus T1 Kelvin. Again, runtime rather. Again, since the temperature difference na po yan, we don't have to convert the following degree Fahrenheit to runtime because it is already degree 1 Fahrenheit is equal to 1 runtime po. Okay po, ano? So in that case po, multiplying all 0.171 times 140 minus 400. Okay, yung internal energy po natin, okay, internal energy natin is equal to negative 419.013.459. That is BTU. Okay? Did you yield the same answer? Answering, unit analysis muna natin. Yan. Okay. Did you yield the same answer po? Okay, okay. That's good. Okay. Yeah. All right. So, and then for letter B, we have here solving for letter D, the transferred heat or heat transferred in pound force feet. All right. So again, in under isometric process, all right? Under isometric process, ang atin pong heat is just simply equal to internal energy. Okay? Okay. Yeah. Simply equal to ang ating pong heat is simply equal to internal energy. Okay? Ano? So just kaso ang pinapahanap po sa atin dyan ay naka-pound force feet. Eh ang ating pong delta U is in BTU. Therefore, we all just have to convert this BTU into pound force. Okay? So ang ating heat is equal to negative 419.0130. So makikikontinue na lang yan. Again, ano pong ating conversion of unit? 1 BTU is equal to 778 pound force feet. Okay? All over 1 BTU. Okay? Cancel. Cancel. Right? And so, simply multiply it by 778. You'll have, ano pong sagot natin? What will be the answer? Negative 325,992,1497 pound force feet. Okay? This negative sign, okay? All right, this, wait lang, box lang ni sir. This negative sign of heat, okay, this obtained value of heat indicates na the transferred heat is ejected. Okay po. Therefore, ang isasagot natin, okay, after nating ma-obtain itong value na negative 325. Correct po yun ha. Correct po na negative 325, 300,000 325,992.1497 pound force feet ang sagot. Or it can be also answered na positive. Okay? Pero you have to indicate if whether it is rejected or added. Okay? Kasi in this case po, okay, kapag yan po ay positive ang nakuha nyo, which is yung talaga yung sagot, okay lang kahit di mo nalagyan ng added. Pero kung lalagyan mo naman ng added, okay lang din. Okay? Pero kapag po dito ang sagot po natin, okay, ang sagot po natin ay negative talaga. So it's either your answer is in negative sign, okay, may negative sign, yung numerical value. Pero kung hindi mo naman gagamitin yung negative sign, make sure na you'll indicate na this is a heat rejected or by just simply including rejected na term dun sa dulo. Nakakaintindihan tayo, guys? Nakakaintindihan po tayo? Okay. Right. So there are two possible ways kapag negative sa heat. Yan. Alright, so since hindi nakasya, edi ating i-save muna ito. Save part file new. Yan. So continuing, okay, we have here and find the Ang sunod na po ay change in enthalpy. Okay? Or delta H. Okay? Delta H for letter E. Second to the last na tayo, guys. Delta H in BTU naman. Okay? Delta H again in all process. Okay? Delta H, okay, delta H is equal to MCP delta T or T2 minus T1. Okay, we already have the value of mass. Okay, so same lang po yung gagamitin na mass natin dyan, which is yung 9.42 4494961. Okay, hindi na i-continue ni sir. But please, when nag-e-exam po kayo, kung di nyo man po yan ma-continue, make sure na kapag kinalculate nyo po, is yung true value. Okay? Pero syempre, kapag yan po yung final answer, or I mean, yung answer, kailangan nyo muna ipakita yung true value. Pero pag sinosolve nyo na, okay lang yan kahit for decimal places. Just make sure na kapag po kayo ay same lang naman yung value, I mean, kung gagamitin sa calculate, basta yung true value yung gagamitin sa calculate. Nagkakaintindihan tayo doon? Okay? And then, after that, okay, what is the value of CP? Okay, ng air. Okay, the value of CP ng air ng English units na is 0.24, right? BTU over pound mass. Okay, runtime. Okay, and then the simply 140 minus 400 for temperature. Okay, unit analysis, pound mass, cancel, runtime, cancel. Okay, what would be the answer? Times 0.24 times 140 minus 400. Alright, so the answer for enthalpy is equal to delta H is equal to negative 588.0884855 BTU. Okay. Did you yield the same answer, everyone? Alright, that's good. And also, I do hope yung iba nagsosolve. Okay? O natutulog na. Okay, yan. Alright. Okay. Okay, down to last one. Okay, the last one or task to find is the change of entropy in pound force feet runtime. Okay, change in entropy or S. Okay. S. Okay, so for S, from the equation ng entropy natin, dQ over T, okay, which is also equal to MCV ln T2 over T1. Okay, entropy can be obtained using the equation MCV ln. Since meron na tayong given dito na temperature 2 at saka temperature 1, we can use this po instead. Okay? Instead na P2 over P. Okay? But again guys, you can still use po the P2 over P1. Okay? Using the pressure 2 na na-obtain natin kanina over P1. Alright? Over P1 rather. Okay? So using the equation, substituting the values, we obtain for mass 9.4244. Okay? So on, pound mass. And then we have CV. Again, the CV po ng air is 0.171 BTU per pound mass. Runtime. Okay? And then, we have here LN. Okay, dito po, you have to convert the following temperatures into an absolute temperature. Therefore, adding both by 460, all right, over 400 plus 460 to make it runtime for absolute temperature reading. Okay, so unit analysis muna, cancel out the following units that are cancelable. Yan. And then it will give us the unit of BTU. Okay, so just simply multiply the following 171 times LN. Okay, LN ng 140 plus 460, 400 plus 460. The answer would be, okay, bakit mali sa akin? 17194. Just meet me at the... Ay, tama pala. Okay, therefore, the entropy Okay, is equal to negative 0.58012 ay sorry, 17,1763159 BTU. Okay? BTU per runtime. Bakit nasaan siya? Hindi kinancel ang runtime. Okay. Dapat BTU lang yun kasi runtime. Okay? Ayan. Alright? So, BTU lang yun, guys.
And correction lang doon kasi medyo nalito lang si sir. Okay? So, yung R na yon kasi dinivide both temperature. So, makakancel yung R mismo doon. So, ang sagot po talaga dyan is PTU per runtime. Okay, kasi hindi po makakancel yung runtime dito. Okay, hindi makakancel yung, ito ba yung aking ano? Okay. Yan kita. Ayan. So, nalito lang si sir. Pero ito talaga, LN, di ba? Yan temperature over temperature. So, tendency, makakancel doon mismo yung runtime. So, ibig sabihin, itong LN, naka-LN ito, magiging unitless. Okay, kumbaga. And then, di ba, ito BTU per pound mass runtime. Yung runtime po doon, hindi yan na-cancel. Okay, sorry for that. Nalito lang si sir. Ano, so, correction lang doon. So, ang sagot po talaga dyan is BTU over runtime.
So, makakancel ang... Okay. Did you yield the same answer? Alright. So, that is for isometric process. Okay? Again, for your assignment, you have to re-evaluate problem number 2 po. Okay, nagkakaintindihan tayo doon? Nagkakaintindihan po? Alright, so let me pause the recording lang.
Okay. So, how was it? May question po ba kayo? Question po? Yeah. Okay. Okay naman tayo? Tama.